right now and see if there's some questions about it. Thank you everyone for joining me. My name is Nico Kabar. I'm a solution architect here at Tigera. And today we are talking about multi-tenancy in Kubernetes and how Calico and Calico Enterprise can enable you to achieve it, basically. So if you haven't been on any of our webinars before, welcome. How we run through this is, have a series of slides. This is a recorded session, and after the session is done, we'll send you the slides and the recording in an email. So if you want to go back and watch it, or use the slides for reference, you'll have access to them as soon as the meeting is done, or the Zoom is done. If you have any questions, please feel free to raise them in the chat window or in the Q&A window, and I'm leaving some time towards the end to answer them. So with that, let's get started. Just a bit about myself. My name is Nico. As I said, I'm a solution architect here at Tigera. Been with the company for a year now, and prior to that was with Docker and Cisco. So pretty much been focused on all things networking, all things cloud, and containers and Kubernetes over the past 5-6 years or so. So if you have any questions, feel free to as I said, send them my way in the chat here, and I'm happy to answer them. So what we'll be talking about today, I'll start off with a quick Calico overview for those of you who are not familiar with Calico itself, what we do, why you should care. And then we'll switch to talk about Kubernetes Multi-Tenancy, what it means, what are the key pillars of Kubernetes Multi-Tenancy, and the kind of primitives. We'll talk about Calico Trust capabilities that are aligned to address some of the key, basically, requirements to achieve multi-tenancy for your Kubernetes clusters and environments. And also talk about, from a compliance perspective, how Calico Enterprise can help you achieve compliance, especially in a multi-tenant environment. And as I said, we will leave some time towards the end. I'm not sure if we'll take the full hour, most likely maybe 30-40 minutes. I don't want to bore you with slides, but happy to take any questions you have and answer them towards the end of the discussion. So with that, let's get going. So if you never heard of Project Calico, it is a community-driven open source project that started around the same time as Kubernetes, providing an open source networking and network security solution for containers, virtual machines, and host-based workloads. Why you should care and why others are using Calico today? Because it's simple, secure, and scalable networking solution for Kubernetes. It is blazing fast since it provides native Linux data plane capabilities, and it is designed to provide a native layer 3 network. Initially, it was no encapsulation overhead, but now you also have the option to use encapsulation as needed. So providing, pod-to-pod networking at scale with this kind of layer 3 networking design. It is massively scalable as it is built on the routing protocol of the internet, that is BGP. So therefore, really, the scale of your cluster is not limited by Calico. It is more limited by the resources, or if you have soft or hard limits from Kubernetes itself. Another point is it is widely adopted within the industry. It is adopted by the major cloud providers like AWS, Google, Azure, IBM as a standard for network policy. It is embedded in hybrid solutions like Rancher and Docker Enterprise from Mitigation, as well as there's tight integration with Red Hat OpenShift. Today, we're certified in Red Hat OpenShift as a operator-based solution for Red Hat OpenShift 4. Finally, in terms of real-world production, use, it is trusted and running in production at large scales, with hundreds of thousands of clusters today, actually closer to 200,000 known clusters that are running Calico today, with more than 1 million nodes that are running Calico in the world. So those are some of the key reasons why users are using Calico today. Again, it's a simple and secure and scalable networking and network security solution for Kubernetes. Now, Tigera is a company behind Calico, and we are kind of the inventors and maintainers of Project Calico, and also helped and co-led a lot of the security group work with other CNCF projects like Istio and Envoy. We also have built a solution called Calico Enterprise that is trusted by top global enterprises. You can see some of the Fortune 500 customers that are using Calico Enterprise today to secure and kind of manage their workloads for their kind of mission critical applications today. Calico Enterprise itself is a hybrid and multi-cloud solution. So regardless of where you're running your Kubernetes, or which distro, what platform, whether it is a managed Kubernetes service, or on-prem or hybrid, or kind of totally upstream Kubernetes, Calico can run and help secure those workloads across single cluster or multiple cluster in a federated way, providing kind of a single network security framework and solution across your Kubernetes environments. So now that we have spoke about Calico, just a quick intro. Let me talk to you about Kubernetes multi-tenancy. Let's start with the key concepts and then dive into the primitives of multi-tenancy, specifically for Kubernetes. So let's start by taking a scenario of a Kubernetes platform team. Some of you might be part of a platform team or DevOps team that is working on a Kubernetes project today. So let's say you're a platform owner that are kind of tasked with defining the platform, creating a platform for internal consumptions for Kubernetes. So you go ahead and after some R&D, you pick a platform, you pick the different components and the design and so forth, and you create a cluster for a group or tenant to deploy their application. Usually there's a use case behind you owning a platform. There's some applications that need to move to Kubernetes or move to the cloud, and take advantage of Kubernetes there. So you create a cluster for this group or tenant to deploy their application. You provide the infrastructure layer, create the control, or create the infrastructure layer, create the control plane for Kubernetes, the Kubernetes control plane, etcd, and so forth. Provision worker nodes to meet the tenant's requirements in terms of compute capacity, network capacity, storage capacity, and so forth. As I said, use a managed or unmanaged Kubernetes solution, start managing the environment for that team. Define, of course, some SLAs and a dedicated team. It could be a team of one, team of many, depending on your environment, and basically work with the application teams to either migrate their existing applications or deploy greenfield application into this new cluster. So you are successful. Another organization hears all about the great stuff you've been doing, so they want to be part of it, right? So they request the same kind of Kubernetes solution. You go through the same process, maybe different requirements on capacity or certain security requirements or so forth. And then you provision a similar environment, set similar SLAs, start managing the environment for them. and applications get migrated for the second tenant or second group. Now, 10 more organizations hear all about the great work you've been doing, so they want to be part of it. There's a pattern here, right? It is becoming an unmanageable and costly solution. If you're taking this approach for every tenant or group or business unit, you're creating a whole new cluster, you're adding more control plane, dedicated resources. Even if for a managed Kubernetes cloud, there's a tax added to managing this those new environments. So you start looking into a way to address the high demand for Kubernetes platform while minimizing cost and overhead. So this kind of brings us to the discussion of Kubernetes multi-tenancy, and I'm going to describe two types that are common right now, and there's probably more, but this is what we're seeing a lot of. One is what we call type 1 Kubernetes as a service. So multiple groups, tenants share the same cluster or clusters to run their applications side by side, utilizing the same set of infrastructure resources. So it's a platform level isolation because they're sharing the same platform that is Kubernetes. The tenants here, or the groups, the consumers of this service are Kubernetes users, and they will access the the Kubernetes API. So they need to have that level of access. Tenants are typically internal to the organization, unless you're a Kubernetes SaaS or Kubernetes PaaS platform. Tenants are internal to the organization. In terms of compliance requirements, they vary. Some could be inherent to your organization, what you define as current requirements for compliance. So basically self-imposed requirements, or some could be regulated or industry-specific set of requirements. The second type of multi-tenancy is if you're trying or you are providing software as a service on top of Kubernetes. In this case, you run an instance of a service per external user of tenant, right? Tenants are external to the cluster or to the environment, actually to the organization. It's kind of opaque to Kubernetes. Tenants do not have access to Kubernetes API. They have access to the service inside of it, and this is basically what we're providing as an application layer isolation, right? It is not mutually exclusive from the multi-tenancy, from the type 1. You can have both types basically, but typically you have other regulations, industry regulations, things like ISO-based regulations, SOC-2, when you are dealing with users or customers' data, sensitive data, contact information, and so forth. There's some other regulation that kick in beyond what you provide, what you require as an organization as a whole. An example of this pattern is, recently I've been working with a few customers of mine where they're taking their monolithic application that was deployed within customer environments, and they're creating a SaaS-based service out of it. And in order to do that, they, of course, one option for them is to create cluster per instance of the end customers. But they came to the realization that will cause a cluster sprawl, a Kubernetes platform sprawl, and therefore they want to run multiple clusters but host multiple users on the same set of clusters using kind of this method. So an instance of that software, or an instance of the database, or an instance of the middle, basically the stack that defines the software is running within, is running per external user, but on the same set of Kubernetes clusters. So those are the two types. Again, they're not mutually exclusive, but they are distinct in terms of what they require and how you can manage them. So what are the benefits of moving to a multi-tenant Kubernetes approach? Of course, you're going to reduce the cost by utilizing the same cluster control plane, compute, storage, networking resources. The second is you're going to increase your resource utilization because you're going to be loading more applications, more higher density of workloads on a given infrastructure. And finally, reduce operation overhead because you don't have to linearly scale the number of personnel or admins to manage those users. So you're decoupling the growth of your service from the growth or overhead of growing your team. So those are the three key benefits of moving to a multi-tenant approach. Now let's talk about for Kubernetes, what are the key Kubernetes multi-tenancy primitives, right? What do you need? What's available for you within Kubernetes, and what's missing? What's kind of challenging to move to multi-tenancy with Kubernetes? So there's 6 key kind of primitives for Kubernetes multi-tenancy. Of course, we begin with namespaces. Namespaces are a great primitive that helps with achieving multi-tenancy because it's a logical way to organize projects or tenants. You can think of it as external tenants or even internal tenants have their own set of namespace or namespaces, and we'll identify to group the logical resources that they create. The second is around network policies. This is a key area for Calico and where Calico fits. Network policies are used to isolate network traffic between namespaces or within the namespace or across namespaces. There's a lot of ways you can use network policies. Calico enforces those network policies and it builds upon them for other key capabilities that we'll discuss in a bit. But it's important that, as you may be aware, if you do not use network policies, you don't adopt network policies, namespaces can communicate within each other. So pods can communicate, and therefore you don't have this layer of segmentation to define your tenants. Third, resource quotas are a native, basically a feature and functionality of Kubernetes to ensure that you can set the right set of CPU, storage, memory, and other resources within and map those to a namespace or a tenant, right? So that way you don't, one tenant does not, go and consume all the memory in the cluster and step on another tenant's deployments and workloads. Now, for 4 and 5, this is how you more on authentication, more user management than I am basically on RBAC. So how you define the tenants, how you can align them. There's lots of flexible ways, whether you align them to groups within Kubernetes, or if you're using a service today, an external service that Kubernetes ties into for mapping, like Active Directory or something of that sort, to map tenants or groups of users with the right set of access to their resources. And then you apply role-based access control to define general roles of those tenants and to define what they can do and what they cannot do within this Kubernetes environment. Now, if you, those are the key, I would say, primitives in multi-tenancy. Of course, if you have certain requirements for what we call hard multi-tenancy, either with defining could be using the same set of clusters, but you are dedicated nodes, worker nodes, and other resources to tenants. Therefore, you are basically consolidating the control plane and using the control plane, but in terms of the compute plane or the worker nodes, those are dedicated per tenant, and that's one approach. Or, of course, the absolute hard multi-tenancy is when you have the same data center VPC, but you have multiple clusters, which kind of defines the whole idea of a single cluster multi-tenancy. There could be some use cases for a hard multi-tenancy if you have certain types of workloads and you need a totally dedicated cluster of clusters for those that require this type of hard multi-tenancy. This is where you can take that approach. But if you can consolidate on a dev or staging QA production clusters where you can group your tenants into and align them to namespaces and use the set of capabilities within Kubernetes and others to provide that multi-tenant environment to those users, this is a great approach that, again, helps with those key benefits that I mentioned before. So I'm going to walk you through 7 ways, now that we define those primitives, 7 ways that Calico Enterprise can actually help you enable multi-tenancy. So one is, we talked about the second primitive, which is around network policy, and that's really key. So application segmentation and application security is key when it comes to multi-tenancy. You can achieve that by using Calico network policy for tenant network isolation. Achieve network isolation per tenant. You can apply it at the pod level, service level, namespace level, service account level. You can do a lot of interesting things to define how those applications that are tied to certain tenants are secured and segmented. You have additional layers of visibility into and logging into what traffic was allowed, what traffic was denied. You can also apply egress access controls via what we call DNS policies. So if in the case you have, and this is the key thing, in the case if you have one cluster, for example, right, and you have a firewall in your environment or security group, typically if you have multiple applications running on the same cluster and the source traffic for all those pods on the same nodes is netted through the same compute nodes, there's no way for you to actually open up a security group or firewall for a specific application, a specific tenant, without opening it up for everyone else. And that's a big risk there, and there's a big security issue, especially in the multi-tenant environment, with both the network policies to define east-west segmentation for your application at the namespace level, the pod level, the service level, you name it, and the egress access controls that we provide. You can actually be more granular in how you open up those rules, where even if 2 pods are on the same node, they can actually have fine-tuned and granular policies applied to them and how they can access external resources based on what we call DNS policies, domain-based rules in your policy definition. The second key attribute of Calico Enterprise that would help you with multi-tenancy is tiered security policies. So in Kubernetes network policies, there's no mechanism to ensure that some policies take precedence over others, and only if one policy is allow the traffic, then or if one policy denies the traffic, then other policies cannot even allow it. In the case of a multi-tenant environment, especially if you're in a regulated environment, there needs to be, typically the InfoSec team, security team needs to define cluster-wide policies around those to kind of impose those or can achieve those requirements, compliance requirements, even though those policies may not be related to the business logic of the application. So they can define, let's say, PCI policies, and only if those policies pass that traffic, then it is those the lower tier, whether it is a platform or the application policies, are then enforced. So the way they're enforced is left to right, top to bottom. So you can create tiers, group policies in a tier, and ensure that certain tiers have a higher precedence and are more critical to be enforced before other tiers and policies get enforced. The third feature here is a compliance reporting and dashboarding. Of course, if you have a regulated multi-tenant environment, you want to make sure that as you onboard more applications, more tenants, for either type 1 or type 2, you have a track record that you are compliant if you have certain compliance requirements, that you can be audited for how if you're securing all the workloads, if you're protecting all the workloads. So we, Calico offers a kind of built-in, a couple of built-in types of compliance reporting to help you manage that. And if you can export those reports and run them on a regular basis as well, at the namespace level, the tenant level, or at the cluster level. The fourth aspect here is the audit logs. Of course, whether we're talking about Kubernetes, wide audit logs, or anything specific to Calico and the Calico framework here. Any interaction with the UI or the API to create policies or create services or create any basic Kubernetes resource, it can be audited and can be tracked here to help you pinpoint any changes that were unintended or changes due to security issue and so forth. So you have a track record of that in the audit logs. Fifth is we are kind of the most native and secure in the intelligent threat detection, protection, and mitigation framework that we have built inside of Calico Enterprise. So what this does is in the case, when you have multiple tenants, you do not want to have, I guess the security perimeter or the boundary needs to be really well established. But in the case that you have any malicious activities, any threats, you want to make sure that you are detecting it as soon as possible, protecting against it, and mitigating it. And because the scale or kind of the impact or the scale or the magnitude, the magnitude of the impact of a threat or a malicious activity is substantial when you're offering a service that is or have multiple tenants using your service, especially if they're of type 2, when you have maybe thousands of users using your service. Any issue, any security issue can actually cause have a large impact on your business, on the service that you're offering, and so forth. So when you're the IDS capabilities we have helps you detect malicious activities, things like known activities or known threats, things like anomalies using machine learning. Jobs for things like IP sweeps, port scans, and so forth. And you can isolate those issues, you can mitigate, you can actually quarantine those attackers, you can trigger alerts based on those attacks, and so forth. So a Kubernetes native IDS is something that can help you with, as you're adopting a multi-tenant solution here. As I mentioned, there's alerts on malicious pod activities or overall activities that alert on. We have a long list of both flow logs based or Prometheus metrics based alerts that you can trigger based on the pod activities, DNS activities, network activities, and you can stream those to your SIEM or any other alerting framework that you use. We provide default templates available for ease of deployments, but again, alerting in a world of multi-tenant is a kind of the first step in understanding that there's something and pinpointing that there's something wrong, and so that helps you accelerate kind of the root cause and kind of isolating the issue and mitigating the issue. Finally, RBAC, everything that we talked about here in terms of the capabilities, both the UI and the API. Of course, the Calico itself is tied to Kubernetes RBAC. So if you're using Kubernetes RBAC, then it's going to be easy for you to adopt Calico. But everything we talked about here is RBAC, and we provide that advanced logging both visually for you. So this is an example where you can actually, if for type 1 multi-tenancy, you can actually give those tenants who have already access to Kubernetes access to Calico Enterprise to help them understand for their namespace, for their own set of services, what the which services are talking to which services, how the network profile, how the security profile is looking, and it can filter based on that. We're adding a lot more capabilities around visualizing service-to-service communication, any issues with that service-to-service communication, all the way to layer 7. And again, as I said, everything that you see here is RBAC-ed. And you can ship those logs wherever you want, the flow logs that are used to define those visualization for you. So as a summary, in order to achieve the tenant isolation and help with multi-tenant clusters, Calico can help with tenant isolation, the capabilities for logging and alerting, the IDS capabilities that we talked about, and of course the proof, the compliance, and audit logs that are available for you to help with that. Now, that's kind of pretty much it on the multi-tenancy aspect of the discussion. One area that we've seen an uptake, basically, or more interest in is around SOC-2, especially if you are dealing with type 2 when you're offering a SaaS service that is running on within Kubernetes, then SOC-2 is probably something that you're already familiar with. But if not, let's give it a quick overview. SOC 2 is basically a set of criteria developed by the American Institute of CPAs to offer guidance and certification for companies that handle sensitive customer data, especially in the cloud, whether you're offering SaaS, PaaS, or IaaS. So it is based on 5 trust service criteria, TSCs. They are around security, availability, processing integrity, confidentiality, and privacy. And those are broken into 9 common criteria that you can see here on the right-hand side. Specifically, we, from a Calico perspective, we address the common criteria 6 through 8, which are around logical and physical access controls, system operation, and change management. So we have a white paper that I can reference here, where we defined those CC requirements that are coming from SOC 2 and what that entails in terms of the requirement itself, and what exactly would then Calico and Tagero's solution, both in the open source and in enterprise, how that can align and address those common criteria. I can't go through all of them right now, but you can see that we put the kind of effort and can provide that to you in the white paper to help you organize some of these requirements and help you can address them, so you can actually accelerate your SOC 2 compliance requirement. That is something that helped other customers that I worked with and other users of Calico today. So I think we talked about the overall benefits of Calico, especially in this multi-tenant environment. Again, providing end-to-end visibility, Kubernetes context-rich flow logs, and network policy workflows. This is key for your multi-tenant environment to address both types of type 1 and type 2 multi-tenancy. With that, I'll kind of wrap it up here. If you haven't worked with or kind of looked into Calico Enterprise, we have a self-service kind of hands-on environment that you can request. If you go to Tagger.io/trial, we give you that environment. You can play around with it, and you can see for yourself some of these capabilities that I was talking about, visibility, threat detection, observability, policy, and application segmentation. So there's some labs for you. So if you have some downtime that you want to use to learn something new, feel free to do that. Additionally, I don't know if I have the slide here, but we also launched our, let me start the slide here. We also launched yesterday the Calico certification. It's a free certification, online certification that you can sign up for. If you go to, I think it was added in the, let me stop sharing for a second. I'll add it here in the chat, so you can go and actually sign up if you're interested. It's free certification, again, talking around Kubernetes networking and network security, and go through key fundamental concepts, and you have by the end of it, you can get this certificate that you can use to help to help with what project you're working on and to gain the knowledge needed to actually run Kubernetes or design Kubernetes-based solution. So with that, I'd like to answer some of the questions that I have received. If you still have any questions, please feel free to add them in the Q&A. Right now, I'm seeing a question for slide 18. Do you have any resources that go into details on tiers? We have a hard time mapping our understanding of existing firewall rules with that of the tiered concept in Tigera. Absolutely. So let me see what's the best way to, in documentation, maybe I can spend some time if I pull in a link. If you give me a second, I can pull that up and can explain that. Let me see. So let me share my screen real quick again. 1 minute, please. Okay, I'm going to share my screen right now, and hopefully, okay, 1 second, please. Okay, so for the tiers, I think this documentation, I'll send it to you again, but think about tiers again. It's not aligned to, so they're not related to namespaces per se. They're not aligned to specific, they're not aligned to a specific tenant or group. Think about them as a way to group a set of policies that you want to make sure that they are handled and enforced before other sets of policies are enforced. A tier has an RBAC, is RBAC. So, for example, only this InfoSec team can add policies to a specific, to their respective tier. And you can see that every item that you see here, that I'm pointing out is a policy, right? So let's say you have the policy to deny cluster ingress and egress of known bad actors. So this is something that you don't want to depend on the individual developer to do, pair their application, because it's more common, right? So the more common, the policies and the security measures that you want to impose, the higher they should be in the tier. So the higher tier on the left-hand side is more important than the lower tier, and the higher policy, top to bottom, is more important than the lower one. So if the traffic comes in and it is applied to a specific set of resources, you can match on all pods in the cluster, all namespaces in the cluster, or select ones. So this is another key thing. Where you place the policy is important, but where is it? What does it match on is important. I mean, similar to a lot of things in Kubernetes, you're going to use labels and selectors. You can match on all the pods in the cluster. You can match on specific pods in the cluster. You can match on specific namespaces and so forth. So you define policies, or the security team defines policies that are enforced first. Once this rule is enforced, if it passes, it's going to go to the next one. If it's allowed, it's allowed, it's going to go to the next one, and the next one, and the next one. And then if you have a pass rule, then it's going to go to the next tier, and so forth until it goes through all the tiers and all the policies that apply to that specific pod, right? So not every policy that you see here is applied to every pod, but how they're grouped and how they're managed, this is where the value of the tiering come in. So again, if the traffic, let's assume that all the policies that you see here, all those boxes apply to pod 1, right? So pod 1 is going to have a series of, any incoming connection or any outgoing connection is going to go through a series of those policies it's going to check, is the incoming traffic coming in from a known set of IPs that you define in the policies? Okay, if it's not, then allow it, and then so forth until it goes all the way through. If at this point it is in this last tier, it is not allowed, or if denied, then it's going to be denied. So the higher tier basically helped kind of funnel this the logic of that your organization has for all pods or certain pods, in addition to the application business logic that you define, or the developer or the owner of the application defines. Hopefully that answers your question, but I can paste this here in the chat. That way you can actually see the results.